Hello everyone, welcome again. This is the third video in graph series. So this video is all about BFS and DFS. So BFS and DFS is a graph traversal algorithm, like how we are traversing the graph from a starting vertex. So this BFS and DFS also used in tree also. In tree data structure also, we can use BFS and DFS to search for particular things or traverse through the tree. But in this video, we will talk about how BFS and DFS is useful for graph traversal. So BFS stand for breadth first search and DFS stand for depth first search. Breadth, what actually breadth means? Breadth means like wide, right? So for breadth first search, we will search level by level. So from one level, I will first search like what are the vertex present in that level. Then for the first vertex, we will go to its own level, then go on. But for depth first search, we will first pick one vertex, then go to its children, then its children, or maybe like from one to another, and then we'll complete that completely, then we'll come back to another one. So here we can take one example. So if you see here, I have just maintained one friendship diagram. So this is Sandeep, me actually. So I have friends like Amal, Nikhil and John. Amal has friend called Tanvir. Nikhil has friend as Rehan and Sachin. John has friend as Nirmal and Sadhu. So if I have to take their names in breadth first search manner, then I have to first check like who are my friends first. Then obviously my name will come first, then Amal, Nikhil and John. Then I have to go to Amal and I have to check who is his friend, Tanvir. Then I have to come back to Nikhil, then check for who is Nikhil's immediate friend, that is Rehan. Then you have to go back to John, not like one level down from here. Then you have to go back to John and check who are their friends, Nirmal and Sadhu. Then I have to come back to Rehan and check who is Rehan's friend, that is Sachin. So if in breadth first search manner, the result will be Sachin, Amal, Nikhil, John, Tanvir, Rehan, Nirmal, Sadhu, then Sachin. But same thing, if we are doing in depth first search, then I will go to first Amal or maybe anyone. So I'll go for this example, I am first going to Amal. Then I have to go who is Amal's friend, that is Tanvir. Then I have to come back to Amal, then to Sandeep. Then I have to check who is my next friend, that is Nikhil. Nikhil's friend Rehan, Rehan's friend Sachin. Then I have to come back. Then John, John's friend is Nirmal. Then I will come back to John again. Then I will check for Sadhu. So in DFS or depth first search, the order will be Sandeep, Amal, Tanvir, Nikhil, Rehan, Sachin, John, Nirmal and Sadhu. Okay. Now here one graph related example we will take and we will talk about few terminology which will help us in solving the algorithm in next video. So this is my graph and here A is pointing to B and C and B has a vertex edge between D, then C has edge between E and so on. So if we traverse in BFS manner, that is breadth first search, then the result will be A, then who are A's friend immediately, that is B and C. Then I will go to B, who is B's friend, that is D. Then I will again come back to C, who is C's friend, that is E and F. Then who is F's friend, that is G. So in BFS, the order will be A, B, C, D, E, F and G. If you see one like similarity or if you want to check one parity here, then you can see it is level by level it is searching. So that's why also sometimes it is called as level order. Okay. So in case of DFS, what will happen? In case of DFS, it will be A, then B, then D, then we have to come back till A, then we have to go to C, then C has relations with E, then E we will go back to C and then check for F and G. So for DFS, it will be A, B, D, C, E, F, G. Now we will all know about like stack and queue, right? So for solving BFS and DFS, stack and queue has one important role to play here. So maybe I have mentioned like color wise which one will fit into what, but if you think, so where we can use queue and where we can use stack. So queue we can use for BFS. The answer we can find now. Why? Because when I am searching who are friends of A, or like who are the immediate neighbors of A, then B and C is the result. Then next step what I am doing, I am going to B and then searching for its neighbors. So if you see here, then I am going to C. That means B and C is my immediate neighbors. So after choosing that, I am going to B. That means first B was in, so I am going to B's next level. And then I am coming for C. So the order, if you see here, A, after that when I went to B and C, then when I get B, I inserted D. Then when I get C, I inserted E and F. When I get D here, there was no child. Then I went to E. E had no child, that's why I went to F. And F had child, that's why I went to G. So in each and every level, when I am getting their neighbors, after that, the first neighbor I chose, I am going to that neighbor's immediate level. That's why Q will fit there, because first in and first out is happening here. In case of DFS, I am going to one particular neighbor's deepest level, that is A, then B, then B, then D. So then I have to come back again also, right, by following that path. So I have to come back to B, and then again I have to come back to A, then only I can move back to C. So when I have to come back, when I have to go deep and come back, that time it is like whatever actually last went inside, that I will come first, right? So that time stack will be very much useful. So instead of stack, we can use recursion also to do the same thing. Okay, so now if now we understood like where to use queue and where to use stack to solve BFS and DFS algorithm. So now one more important thing to play a role is, so before that I will first come into the problem, that is if I have any cycle in the graph, suppose it is a directed graph where actually directions are also maintained, like A has connection with B but B don't have any connection with A, such kind of situation. So if C has connection to F and F also have connection with C, that time it's a cycle it is forming. So that time when I will check for like who are the C's neighbor, then it will call E and F. Then when I will come to F, who are the neighbors? G and again C. Then again I will go to C, again I will come to F, then again I will go to C. So that way one cycle will form. So we can never get into a result. So for that purpose, we need one thing that is called visited flag. What it will do is, whatever vertex or node we are traversing, we will mark that as visited. Then if it's a visited, I will not go for that. So suppose when I will come to F, as already C is visited, so I will only choose G, I will not choose C. So that's why visited flag will also play a big role when solving BFS and DFS algorithm. Generally, this visited flag we maintain as a Boolean array where the length of the array is the number of nodes or vertices. So next video we will see the implementation of DFS and BFS using Java program. So there I will explain the concept, then any language you can choose to solve that. So as a single video will be of large size, so I will first BFS video I will make using Java, then I will explain DFS in a separate video. Thanks for watching.